7.6, factoring when a is a fraction. So what I'd like you to do is to practice factoring by solve by factoring this problem here. So I want you to write this down, equation down, and pause, factor it, and then come back to check your answer. Well, welcome back. So the first thing we want to do for this one is, I notice, and we forget, is hopefully it didn't take you too long because there is a greatest common factor here of a -2. So I'm going to pull out a negative because I want my leading coefficient here to be positive. So that would be a -2 outside, and we factor that to 3y squared minus 16y plus 5. And what this does is it helps us easier to factor this this trinomial here. So, and because it's an equal sign, remember, because it's an equal 0, we can divide both sides by -2. And it won't change our solutions. It changes the original equation, but it makes it easier to solve the equation. And remember, we're solving a quadratic. We're solving an equation. So 0 divided by -2 is 0 still. We still have that 0. That's why this process works. So now we can think about how do we factor this. I like that both 3 and 5 are prime numbers. So I'll get my structure set up. My middle term is negative. My end term is positive. So that means I have a minus, minus. I've got my 5 and my 1. And then I need my 3 and 1. And actually, I have a big number. So I want to put my 3 here that multiplies with the 5 is 16y negative, or 15y, and I'm going to subtract 1y for the middle term, and that is my -16, so that checks out. So bring down my equals 0, always bring that down. So now we have 3y minus 1 equals 0, and y minus 5 equals 0. So we'll add 5 to both sides. So y equals 5 is one solution. And plus 1 to both sides. 3y equals 1. Divide both sides by 3. So y equals 1/3. So my solutions are y equals 1/3 and 5 are the solutions to this problem. So now if we look at more complicated one, well, it is more complicated, but actually it's a lot easier than that one beforehand. If we think about how do we solve it. So if we have 1/4 x squared plus 3/2 x plus 2 equals 0. So if we were to factor this, yes, you can factor it, and you get into this like, okay, so we have x plus, and well, to get 2, we need a 1 and a 2, and then we have to think of a factor to multiply, and it gets a little bit more complicated that way. So what I do is think about, well, how can I make this solving an equation easier to solve? And I've thought about a different problem that we've used in the past. If we have 0.3x plus 0.7y equals 0.2. So what can I do to this equation to make it easier to solve or write the linear equation? Well, I could multiply both sides by the same number. And since it's the decimal I want to move, I'm going to multiply both sides by 10. So that would be 3x plus 7y for my distributive property equals 2. So now when I want to solve for y, it makes the numbers a lot easier to work with in that equation. So I'm thinking to myself, how can I use that same idea for my quadratics? Well, what makes this complicated, this problem more complicated, is this denominator, well, the fraction, but it's really the denominator of 4 and 2. So is there a number I could multiply both sides by to make it easier? And it's that greatest common denominator. That greatest common denominator would be 4. So I'm going to multiply each one of these terms by 4. And don't forget, I have to multiply the other side of the equation by 4. But because it's 0, 0 times 4 is 0. Bring down my equals. So that means 4 times 1/4 is 1. So I get an x squared, which I like that as being a 1. 4 times 3/2, that would be a positive, well, 2 times 3 is 6x. And don't forget, you have to take 4 times 2 is 8. And now when I factor it, bring down my equals 0. Don't forget to do that every time. I have x plus and x plus 8. Well, to get 8, I do 1 times 8. No, 2 times, there it is, 2 times 4. So now that I can use my 0 property product, x plus 2 equals 0 and x plus 4 equals 0. Minus 4 from both sides and minus 2 from both sides here. So x equals -2 and x equals -4 as my solutions to my quadratic. Remember at the beginning, that's this fraction, that's those numbers. Well, but it's actually easier once I have kind of nice whole or integer numbers to work with. So to write it on my answer line, I would start with the smallest and move to the largest. So now if we think about a problem, okay, let's do a word problem. So here we have a bouncing ball. So number 3 is bouncing ball problem. So if we have a bouncing ball, and remember, a ball will bounce. So if we have our ball and it bounces, it's going to hit the ground and it's going to bounce up and over. Well, we'll do bounce again. But if we look at kind of one of the bounces, it can be written with an equation y equals -16 t squared plus 20t. Now, remember we had this initial equation for, well, it's gravity. We know it's gravity on Earth because of this -16 in front of our t squared, the leading coefficient. So remember our y equals -16 t squared plus the velocity of 0, t, plus the start of 0. So we can look at the velocity here is a plus 20. So what that plus 20 means is this part right here where the ball is bouncing up and going up and over. So that plus 20 is our velocity of our ball bouncing off the ground. Now, if we think about, and then it'll hit over here at this point here and this point here. So where is our starting point? So that plus 0, which means that that starting is right here at our, when t equals 0. So we start that point at t equals 0. So, wait, these 2 points right here and here are our x-intercepts, remember? And what do we know about our x-intercepts? Y equals 0. So when y equals 0, that puts our 0 in our equation. 0 equals -16 t squared plus 20t is our equation to find our x-intercepts here, where the ball bounces. And we can tell how long it's been in the air because our independent variable is t, which is time in seconds. So that's our t, and we can tell how long it's been in there between our 2 points. Now, the y value is our height in feet. So it'll be that height in feet because it's always that negative 16 is seconds in feet. So now we can solve it by distributing out a negative 4. I'll pull out a negative to make this front term a positive. So that would be 4t squared. Oh, wait. I can pull out a t also. So that squared is just t times t is t squared. Now I do need to make sure that this is negative because a negative times a negative is a positive. 4 times 5 is 20, and t times that is t. So I now have 2 factors, so I can use my zero property product, and you've probably noticed now that the negative 4, I could divide out that negative 4 from both sides, so it really doesn't affect the t equals 0. So that's our initial 0, that's that starting 0 right here is 0. And 4t minus 5 is also equal to 0, so we'll add 5 plus 5. So 4t equals 5. Divide both sides by 4 to find that t equals 1 and 1/4. Now this one I'm going to change to an improper or a mixed number because that means a little bit more to me rather than the 4/5. So that means we have a 0 bounce, so it bounces at 0. When it goes up and over, it bounces again at positive 1 and 1/4 second. So the ball will be in the air 1 and 1/4 seconds long. And that's our intercepts for those. That ball being in the air. Now, a couple other things. We could also figure out how high it is. Well, I don't know if you've noticed this before, but we could find that, you've done some other problems where it's the middle term, like it's kind of right in the middle of those two. So we could find the middle of that and find that maximum height too. But this question only asked, how long was it in the air? And it was 1 and 1/4 seconds in the air.